Hello everyone, welcome to another episode of our design pattern series here at Code to Commerce. I am Mayank Pratap Singh and today we are going to explore the decorator pattern. What exactly is the decorator pattern? Well, imagine you have a plain cup of coffee. It's basic. But what if you want to add some flavor to it? You might want to add milk, sugar, or maybe even some syrup. That's essentially what the decorator pattern does. It allows you to dynamically add new features or behaviors to objects without changing their original structure. Now, why do we need this decorator pattern? Let's say you have a class representing a basic object, like our plain cup of coffee. Instead of creating separate subclasses for each variation like coffee with milk, coffee with sugar, and so on, the decorator pattern lets you add these variations dynamically. This makes our code more flexible and easier to maintain. One of the best real-life examples of the decorator pattern is in the food industry. Think about a simple pizza. You start with a plain crust, but then you can add toppings like pepperoni, mushrooms, or extra cheese to customize it as per your liking. Each topping acts as a decorator, enhancing the pizza without changing its original structure. Now, let's dive into some code examples to understand how the decorator pattern works. In this incorrect implementation, we will start with a basic coffee class and attempt to add milk as a decorator. Here, we are attempting to add milk to our coffee class by creating a subclass called coffee with milk. But this approach is flawed because it violates the open/closed principle. We are modifying the existing class instead of extending its functionality. Now, let's correct this using the decorator pattern. In this corrected code, we define a beverage interface representing our basic coffee. Then we create a concrete implementation called basic coffee. Now, to add milk as a decorator, we create a milk decorator class that implements the beverage interface. This way, we can dynamically add milk to any beverage without altering its structure. And the same thing happens with the syrup decorator. Also, think about this. If we want to add more ingredients apart from milk or syrup, that ingredient would easily fit into this current architecture because of the loose coupling. Decorator pattern allows you to change the order of adding ingredients to the base component seamlessly. It would just work. This demonstrates the elegance and the flexibility of the decorator pattern. It allows us to add new features to objects dynamically, making our code more maintainable and adaptable to change. So, whether we want a plain coffee, one with milk, syrup, or even both, the decorator pattern is there for us. Now, let's weigh the pros and the cons of the decorator pattern. Starting with the pros. Flexibility. The decorator pattern allows for dynamic and flexible behavior extension, open/closed principle. By extending functionality through composition rather than inheritance, the decorator pattern follows the open/closed principle, promoting the code that is open for extension but closed for modification. On the flip side, let's consider one of the cons. Complexity. Using multiple decorators can lead to complex interactions and make the code little bit harder to understand. Now the wrap-up part. Overall, the decorator pattern offers significant benefits in terms of flexibility and scalability. However, It is essential to weigh pros and cons against the complexity or the performance implications in your specific project application. Please subscribe, like, share, and hit the bell icon to stay updated with the latest videos. See you in the next episode.